So I've been tracing out the board for the PA948 this evening. A bit of reverse engineering, because some basic probing around, like, you know, trying to check transistor junctions and stuff. Nothing seems to be apparently wrong. However, this is just, yeah. So I've got some bits of paper in front of me, and this is the only way I can explain how bizarre this is. So on my last video I said this was the output stage, a triples configuration. Well, I was wrong. It is a triples configuration, but it is the oddest. So where am I? So you can see various sketches. You sort of sketch something out and then try and tidy it up. So starting with the output stage. So this bit is just like a driving point from the input stage to the output, so ignore that. Again, this is just sort of the lower half of the output stage down here. So along here would be a line of all the parallel output transistors. So here's just one pair, so they've all got 0.33 ohm emitter resistor. They all have a 10 ohm base resistor which comes to the drive signal, and then there's a final 100 ohm common between all of them from the drive signal to the output. So the driver stage for the outputs is an emitter follower stage. So it has a 10 ohm in its emitter going to this main output rail, and then each output transistor has 10 ohms going to that point as well. So when you have two emitter followers on the output, you generally expect the third stage to be an emitter follower, but it isn't. It's a common emitter amplifier, and I've checked this multiple times. I have definitely not got this wrong, and this is just where it's confusing. So on the upper half there's a common emitter amplifier. So pick and place. The reason you see random like lots of 10 ohms instead of 20 is because when it's the pick and place machine manufacturing, instead of having to put in a reel of 20 ohm resistors, you just put in 10s and double them up on your board. You know, you only have so many reels you can fit on the machine in one go, and if you run out of space and have to send your boards through again, it's expensive. So you minimize on the components and just double up on some of them, parallel and whatever. So comes out of the collector from this common emitter stage, feeds into the base of this, then there's some cross feed thing going on to this lower one. So basically these bases, the bases, so these bases need to be about 1.2 volts above the output rail. So this one would be like minus 1.2, this one at plus 1.2. And that means these collectors do as well. These transistors will have full rail voltage across them, and they don't appear to be in like any kind of feedback loop in the standard configuration, because in the local feedback loop here, this half, it self-stabilizes. This, yeah, I'm not really sure what's going on. I know I've still got some more components to trace out, but there doesn't really seem to be a lot else going on in this output stage, so I need to have a cup of tea and think this over. It's the joy of bits and bobs. Like for instance, last video I was on about that little board in the amplifier, but I didn't really know what it did. And literally about half hour after I made that video, I was just sat on the sofa drinking a cup of tea. I was like, well, it's obvious what it does. It's got the 22022 winding from the power transformer going into it, and a relay that turns on as soon as you apply power. Because the second power is disconnected, that relay will close. That then disconnects the output. So where the mains will come into the amplifier, it disconnects that. And that little board is then basically a 50 Hertz inverter circuit. It will generate a 50 Hertz square wave, back feed that into the power transformer. The power transformer then runs as a step-up transformer from the 24 volt and powers the amp. And the second the mains power returns, that relay opens, and the whole thing switches off and away it goes. Dead simple, made sense, but it was one of those you just had to walk away and also click. Oh, of course, yeah. So yeah, this, I need to think about what's going on here. Like I said, I'm certain I haven't made a mistake. That doesn't mean I haven't. It just means I'm certain I haven't. Yeah. Everyone who makes mistakes is certain they haven't made a mistake. That's how you make a mistake. If you wasn't certain you'd made a mistake, then you wouldn't have made the fucking mistake, would you? So that's the output, but what really gets weird on this amp, so here was the original, just tracing the input and some of the signal routing. You can see a bit of a messy diagram, so you start off like this and then you kind of redraw it. So simplified it just down to the 4 input transistors, so forget the drivers, forget the output stage and all that lot. I had to redraw this out because even this is weird. So this is where the input signal comes from. So you've got your audio coming here, and that's the 0V point for the audio where it connects. Now there are some weird, so if you look where the pen is there, there's a 10 ohm, oh no, sorry, that's the bias circuit, not that one. There's a 10 ohm resistor which has been tacked onto the board there, and if you look where the pen is there, there's a blob of solder where it says there should be a resistor. So now when you follow the signal tracing, it comes in on a 0.47 mic cap through a 2K resistor. So this is basically a symmetrical input stage. Now this signal, that resistor which is bypassed with a 10 ohm resistor is this one here. So I did do the maths. So I did the maths. Without that 10 ohm resistor in, a 1 volt signal coming in will be a 0.74 volt signal going to the bases of the transistors. With the 10 ohm resistor in, a 1 volt signal coming in becomes a 5 millivolt signal to the bases of the transistors. Now, I don't know if you can remember, but I did say in the last video about how much the voltage changed on the output relative to load, which made me think, well, this thing can't be running a lot of negative feedback because there's just very, very high output impedance. Well, it's not running any. So I've missed some components off. I've not put the bias circuit in. There's like a DC offset trimmer comes here as well. So the output rail comes through a 56k resistor, and it comes back to the bases of these pairs. So these are the input transistors, and these are the feedback side of the input stage transistors. However, that 0V solder blob, which resistor value that was originally there unknown, not printed on the board, just a blob of solder, comes along here, connects through 100 nanofarad and 100 microfarad cap, and goes to the input. So we've got no feedback, so we've got an amp with a shit ton of gain, and then to combat the fact it's got a shit ton of gain, this resistor here, which was basically the input impedance bias resistor, so it's just the reference for these transistors to 0V, and then you select your components based on certain criteria. Because this thing would just go to full power with the most basic, like just whiff of signal, then there's been this 10 ohm resistor tacked across here to attenuate a 1 volt signal coming into just a few millivolts going to these transistors. That would explain why there's so much noise. Again, if you look at the last video, I'm getting loads of noise coming through. There's the buzzing and everything. That would explain that because there's no feedback, there's no correction of that. I did actually, after taking this out, manage to get it to bias up more, and it stopped buzzing and just went to a real loud hiss. If you ever heard like a cheap amplifier with a real noisy power supply in it, you can just hear it hissing. It sort of sounds like air coming out of a fan, but loads. It's like white noise basically. It was doing that instead. So now I'm going to say I'm going to start with a 1k resistor here. Generally amps have somewhere around a 1k, 22k and 1k would be an amp with a good chunk of feedback. It's a triples output stage, it's got a lot of gain, could have stability issues, so you'd probably 56k 1k. But so yeah, take this out, put a 1k in there. Let me do some maths a second. Yeah, ignore the up there, I kind of went off track there. Yeah, so I can't remember where I last was, so I'm going to repeat the bit I said before, and if I haven't said it before, I shall leave it in. If I have, I shall edit it out. So if you go on the assumption that the 5 millivolt signal is enough to drive it to full power, 53 volts RMS would be about 75 volts peak on the output, which is about right. The gain of the amp would be about 10,600, which it possibly is. Maybe, who can say? So working out the figure of a 750 millivolt signal, so I'm basing it on that there's 1 volt coming in here and it's the same level of attenuation. It's the same signal here, but the different levels of attenuation present a different signal at this point. And so yeah, taking this out, you get 0.75 volts. It works out to get the amp to full power with the same amount of signal here. This resistor here would be about 820 ohms. If you just crunch the maths, you basically get, so you get a ratio between, you can almost just do that over that, but you need to do that over that and then actually sort of add that bit to it to get better accuracy. So 56,000 over 820 is 68. So 68 times 0.75 gives 51. So there'd be 51 volts across that, but of course there's another 0.75 across here, so it has to be that much higher. So plus the 0.75 and you basically get 52 volts at that point, which is close enough. So yeah, so I think that's the resistor to go for. So I shall unsolder that, put an 820 ohm in there after removing that solder blob. Feedback's going to help. Whatever that problem is, feedback will definitely help it, but I don't think that's going to solve it. It might do, and you have to ask why the hell the amp was built like this, and if that was the problem, if that's going to be the problem, how did it get past whoever did this? But yeah, trying to run a transistor amp with no negative feedback, there's got to be some local feedback thing going on in this output stage, because otherwise it would just go mental. Yeah, I need to sit down and have a think about what's going on there, but that's a video for another day. It's getting late at night again. It's a pain in the ass trying to, you're literally shining a torch through the board, trying to like put your finger on a little wire, and which one was it? Which one's my finger against? Is it, which one is it? Is it that one there? Is it that one? And then you're back on this side and you, no, I've moved, I've lost my finger, and you're back here, and yeah, and you're having to get the meter out and probe to make sure what you followed actually does match to what you think you followed. So yeah, I've basically got this, most of it done. There's some fan controls and stuff on here. I want to know what's going on with this input jack as well. There seems to be more signals coming from the board, and there was an op amp up here, so I don't know if it was originally designed to take a balanced input signal. Yeah, who knows. So service manual would be handy, but you've got no chance of finding one of them. So yeah, anyway, just more waffle from me. I just had to make the video. I just thought I need to make the video because this is just confusing me now. I was like, I'm going nuts here. And yeah, just this is where, I mean, the output stage is, you know, I'll get my head around that at some point, but this, why this has been done, I do not know. So yeah, anyway, yeah, if anyone's got any ideas, always feel free to comment. You know, it's always good to get someone else's perspective on something. But yeah, anyway, thanks for watching and catch you next time.